So there is possible national involvement in some of the results given
yes,
by
I
Zadko.
think so. Yeah.
There was a recent Senate report highlighting the deficiency that Australia has in dealing with and protecting their they call it space-based assets, and so it is becoming increasingly important now for Australia to play an active role in protecting their own space assets and not relying on foreign countries. So I think it is perfect timing now to be involved in this research, and we're lucky that Murty's PhD was in tracking space debris, and we've just established the new France-Australia robotic telescope network. So as Murty stated, now we can be tracking the debris around a significant fraction of its orbit. We don't have to wait until the following night because of this longitude issue. That's why a telescope array is so important. So it's a really exciting time to be starting the space debris research.
I believe that, in fact, the government must agree with you, because you've actually received some funding to get this far with the Zadko project. And I think perhaps just some more funding is possibly needed just to complete some of this. So the fact that the government is actually very confident in the outcomes of this particular project is a good statement on UWA science, I think.
Oh, absolutely. We've got what's called a collaboration grant. The French government are contributing funds for researcher exchange. This type of research requires two key things. It requires very high quality equipment and also expertise. And both those things are quite expensive. So what we have to do is bring those two things together. This collaborative grant allows French researchers to visit Australia to work on our project, and also us to utilise some of our equipment, and for us to work together to really get this thing happening. And that's what the pilot project funding has allowed us to do. So we're very encouraged by that, but we will be requiring more funding. This type of project isn't a 6-month project or a 1-year project. This is a 5-year project at least. We cannot expect to have to achieve our scientific goals within 1 year.
Okay, and I think in keeping with UWA excellence, I believe that Zadko may fit into other projects that are being progressed in UWA, like the square kilometre array.
Well, the square kilometre array is a frontier project that will revolutionise astronomy. It will allow us to probe back to the deepest depths of the universe and to watch the first stars forming in the radio spectrum. The amount of data that will be processed is phenomenal. It's like the whole internet usage compressed into one day. The whole internet usage for a year compressed into one day. It's a phenomenal amount of data storage. This is the largest international big science project around now, so it's great that UWA is a part of that, because Australia is putting in a bid to host the SKA, and UWA has got a very strong presence in trying to attract that bid. And in fact, they're building what's called a Pathfinder Radio Telescope in Western Australia, which will be a cutting-edge instrument on its own right, even before the SKA. And then we've got gravitational wave research. Australia, UWA is part of an international effort called the LIGO Scientific Community, which is about 1,000 scientists, and they're involved in searching for gravitational waves predicted by Albert Einstein back in 1918. But no one has actually measured these things, and so there is a huge international effort to observe ripples in space-time being stretched and squeezed, and the types of objects that produce this type of radiation, black holes and exploding stars and all these really exciting things. So it's great that UWA has got this new and growing presence in frontier astronomy.
And yeah, it sounds pretty exciting. The future looks very bright over here. And I guess in keeping with those frontier projects, there's a lot of challenges. What was the most challenging problem, David, that you had with the Zadko project?
With the Zadko project is very much a logistical problem initially in getting equipment to work, and secondly to get the right people. And it is very, very hard to do this without expertise and to have the right people. So we've been working very hard with our French collaborators to set up a collaboration where we can make this France-Australia telescope array, and that has taken a lot of commitment and a lot of time from various people. It's been a big investment, and I think that's been the biggest challenge so far, and I know we've probably got bigger challenges ahead, we just don't know what they are.
This is just the tip of the iceberg. So Mriti, what was your particular technical or otherwise challenge?
I'm just here since 2 months, so I think the most challenging thing is just to have all the things working together and really achieve the linking with the French network and to have something really working well. So it's I think now the most challenging thing will be to make a big science and to make image of transient, like gravitational waves or something like that. This will be very good and very. This is really challenging thing because
it's difficult
because we need to make the telescope answer very quickly and to have all the software very secure to make this image and to because it's autonomous telescope. We are making image with no people inside the dome, so it's we have only software on computer who manage all the observatory, the weather, the opening of the dome and the closer, and the moving the telescope and the dome on the good position, etc. So there is no human to make this, and if we are receiving an alert, we need to answer very quickly, like in 2 seconds, and to make the telescope pointing on the good direction. So this is a big challenge.
And we're just starting the LIGO triggers, which LIGO is the gravitational wave telescope. It's a $500 million US big instrument to detect gravitational waves. They're just starting to prepare to send us triggers, to send us positions in the sky, and this is a first. This is the first time that Australia will be doing this, and this is happening right.
Yes, we will
next
make
week?
Next. We are making some tests. Yeah.
Okay, I'll come back next month and we can actually see the results. Okay.
But the test will be a long test because we're until October, so you can come back in November.
Okay.
Yeah.
In Christmas, anyway.
Yeah, when it's not raining as well.
Oh yeah. Well, obviously it's a resource-efficient system that you have, and all you need is a mobile phone, I guess.
Yes.
Yeah, not even a mobile phone.
Not even. It's fantastic.
No.